A truss is composed of members AB, BC, CD, AD and BD as shown in the figure. A vertical load of 10 kN is applied at the point D. The magnitude of force in the kilonewton in the member BC. Okay, so here this is the truss and here A, B, B, C, C, D, D, A and B, D. Okay, here we applied the 10 kN and we need to find out the force in the BC. Okay, they are not asking force in the BD. Generally they will ask whether there is a force in the BD or not. Okay, so since it is a triangle, actually what happened, the force in the BC will become BD will become 0 from our rule. What is that? You have collinear here and this is perpendicular to that. Okay, whenever you have the triangle, you know, these two will take, it won't give to this middle one. Okay, but anyway they are asking in the BC. Okay, so when they are asking in the BC, then how will you find out? You need to know the reactionary force at the C so that you can find out this. So how many reactionary forces are there? Both are revolute joints here. Okay, both are revolute joint. Whenever you have both the revolute joint, then how are the reactionary forces? This is the RCY and this is the RCX. Okay, and here this is the RAY and then this is the RAX. Okay, so here in reactionary forces we need to find out very quickly. Okay, that itself will consume more time in this problem. So here RAY plus RCY equal to, according to the sigma f y equal to 0, from this what happened, these two are going up and it will compensate the downward force, that is a 10 kN here. Okay, actually because of the symmetry what happened, RAX equal to RCY equal to 5 kN it will become. Okay, because this is the symmetry. And have they given any dimensions? Instead of giving dimensions they have given the angle. Okay, and here sigma f x equal to 0, that means here RAX equal to RCX. Okay, actually no, in the examination because of the symmetry what happened, RAY plus equal to RCY equal to 5 kN. Okay, straight away we will write like that, but anyway in this, you know, we will try to see this. So here I will apply moment at A. Okay, if I apply the moment at a point A, sigma MA equal to 0, that means, you know, what are the forces that are acting here. So here what is happening, this is a 45 degrees. If I take the triangle ADB, in the triangle ADB what is happening, this is a 45 and this is a 90 degrees, then it will become 45. Okay, and here it is a 45, this is a 90 degrees, so here it will become again 45 degree. Okay, so this itself is a right angle triangle. Here it is becoming the 45 and see this will equal to the this, and here this is equal to the this and that equal to this. Okay, so AB equal to BD equal to BC and AD equal to DC. Okay, that is what happening here. Okay, otherwise, you know, I will take this as the length L and this is L and this is the L and this is the L1 and L1. So if I apply MA equal to 0, what are the forces? 10 kN, which is at a distance of L. So 10 into L clockwise, and the RCY is a minus RCY, which is going in the opposite direction, 2L. Okay, equal to 0. So RCY is how much? Equal to 10 divided by 2 equal to 5 kN. That is what I have been saying. And here RAY. Okay, RAY is how much? RAY equal to RCY equal to 5 kN here. Okay, that is what happening. Okay, and here one more thing you need to observe. What is that? See here what is happening. RCY we found out, and the X component we need to find out. Okay, so how will you find out the X component here? So here the finding the horizontal component is little bit tricky. Why? Because here, if I apply the moment at C, then what happen again? You will find the a y, but you cannot find out the a x. Why? Because this is a passing through this point. Otherwise, if I apply at the point B, even in that case, you are unable to find out anything. Even if I apply at the point D, then what happen? Since both are symmetric and equal, then you will get the zero value. So how can I find out this? So the only way is here. What is the FBD? FBD here in this case will become 0. Why? Because this is a triangular, so that these two will take the forces. So this will become a 0. Okay, FBD is becoming 0. So what is happening? If I take the junction D here, okay, at this junction D, what is happening? This is the D. 10 Newton is acting downward, 10 kilonewton. Okay. So here 1/4, because these two are being compressed. So when I write a compressive force like this, then I need to extend like this, right, away from this, and this is the extended like this. This force is how much? FAD, and this force is a FDC. This is at the point of D. You understood what I wrote? See here, what is happening? This is subjected to the, for example, here this is subjected to the compression, because it is trying to compress. So when I write compression on this, on the element it is like this, on the junction the direction is like this. Understood? On the same way, if I write for this element compression, it is like this on this element, and on this junction it is like this, opposite direction, right? The forces on the element and the junction are opposite direction. Okay, so here here the angle between these two is 90 degrees. Okay, then by using the Lami's theorem we can find out what is that. The 10 divided by angle between these two is sine of 90 degrees equal to FDC divided by the angle between these two. Okay, how much? This is the sine of 90 plus this will become how much? 45 degrees, and this will become 45 degrees. Okay, so sine of how much? 135 degree equal to FAD sine of 135. Okay, that is what happening here. That means FDC equal to FAD equal to how much? 10 kilonewton. Okay, this is the 10 kilonewton. So whenever it is the sine 45 will go to other side, right? So 10 by root 2 kilonewton. Okay, so 10 by root 2 kilonewton, and here at this junction C, what are the forces that you have? See here, this is a one force. Let's when it is trying to compress, then it is subjected to the tension. Okay, whenever it is subjected to the tension, then it is on the junction it is like this force, and here this is the vertical force, how much, and this is the subjected to the compression. So this is the RCY, this is the FBC, okay, and then this is how much? This is the R, this is the FDC, and here there is one more force. What is this? This is the RCX. We don't know in which direction it is going, so I will assume like this, it is going like this. So from this, RDC can be written into two components.